Hi, my name is Pam Knox. I'm the director of the University of Georgia Weather Network, and I'm also the extension climatologist for the University of Georgia. And I appreciate the chance to speak with you today. Also appreciate the chance to do it by video. It saves me a lot of driving, a little hard on my bones these days. So anyway, let me go ahead and start my slides, and we will jump in and see if we can give you some good information. All right, I hope you can all see this. Um, what I'm going to talk about today is Georgia's climate outlook in 2026 and the impacts on trees and forests. I also wanted to spend a little bit of time talking about longer term climate impacts, just because I know as foresters, you're concerned with what's going to happen to trees once you plant them. If you're a commodity farmer, of course, you're only really worried about 1 year, but if you're planting trees, you have to look a little bit further down the road. And so I'm going to spend a little bit of time talking about that. Then from there, I will jump into a review of 2025 and what we expect in 2026 and how that might affect your plans for the coming year. So let me go ahead by just starting to say, first, I'm going to talk about what is climate and some of the long-term changes that we're seeing in climate and how those affect forests and foresters. So that will be the first, say, half of my presentation. And then I'm going to jump from there into 2025 and then what we can expect in 2026. So let's go ahead and get started. First of all, what is climate? If you ask the average person on the street, what is climate? They would probably tell you it's the average weather. And that's true, but it's really a whole lot more of that. I think of climate as really describing two different kinds of things. One is how things are changing over time. And you can see that that really is shown here in the top graph, which is a graph of the Georgia average annual temperature from 1895 to the present, or at least the last full year, 2025. Lots of interesting things in there, lots of ups and downs. For if you're a commodity farmer, of course, you probably know that whatever happened last year is probably not going to happen again this year. But there's also some longer term ups and downs that I think are really interesting to look at. And we'll look at those a little bit in just a minute. But you can also talk about how the weather and climate varies across space. And the map on the bottom shows that. So you can see that there are areas, especially in the Southeast this past year, this is for January through December of 2025, where the southwest part of Georgia especially has been in the top 10 driest um, of all years. So that has been something that has contributed to their increasing drought that they've seen over time. You can also see there's a little area to the east of Atlanta that is green, which is a little wetter than average. That a lot of that is due to one storm that happened in early August, where some places there got about 10 inches of rain in just a few days. Throws off the statistics a little bit. But overall, it's a different way of looking at climate. It's a spatial look rather than a time look, and it's more of a snapshot. So when I think of climate, I think of it as describing not only the averages, but also looking at the extremes. How hot and how cold did it get? What range of values did we go through? Cycles, of course, the seasonal cycle is very important, but other cycles like El Nino and La Nina are things that we look at as well. And then also trends. So let's go ahead and look at some of this. The first trend we're going to look at is the temperature trend over time across Georgia. And this is the graph of temperature versus time, annual average temperature from 1895 on the left to 2025 on the right. And a lot of ups and downs, but there's also some periods where it's going up. I drew a blue line on there to show the long-term trend over time, which is increasing. But it hasn't been increasing evenly during that whole time span. And if you start in 1970 again, which turns out to be a pretty key year for climate, you can see the temperature has been rising a lot faster than the very longest term average. For most people, farmers are about 60 years old on the average. So that's a little bit more descriptive of what they're expecting to see. The green line on there represents the current average or normal temperature from 1991 to 2020. And you can see that the last almost 10 years now have really almost all been above that long-term average. So that long-term average may or may not be really depicting what's going on in our climate now. So you might ask, well, we see these periods of rising temperature, but there's also this period from 1925 or so to about 1970 where the temperature in Georgia was decreasing. And it's interesting to look at that because it's related in part to trees. We know that during that time we had a change in the land cover across the southeast of going from mostly bare ground crops like cotton to much more forested. Georgia now is about 60 to 70% forested. So trees really help cool things down overall, so that contributed to the cooling temperatures. Another factor was that during that time period, there was a lot of coal burning going on in the Midwest, which is where I'm from. And during that time, all that coal put a lot of black soot into the atmosphere. That black soot effectively kept sunlight from reaching the ground, and so that helped to cool things off. And in 1970, the Clean Air Act came into effect, and that Clean Air Act cut out a lot of that black soot emission. It was mostly done for a human health standpoint, but it also was done to prevent some of the problems with acid rain. And so at that time, the air was cleaned up a lot and became a lot more transparent. And so more sunlight was able to reach the surface. And so temperatures in the southeast went up really in conjunction with every other part of the country and also of the world. Most of the rise of temperatures from 1970 to the present can be linked to increases in greenhouse gases in the atmosphere. And so there's a few other sources as well, but that's probably the number one source. So that decline was caused in part by changes in land use, as well as changes in the atmospheric chemistry. We look at precipitation trends over time. This is the annual total precipitation for each year for Georgia, again, starting in 1895 on the left and 2025 on the right. You see that year-to-year variability. There is a slight increase in the annual average precipitation. It's really far outweighed by this year-to-year variability that we're seeing. But overall, things are getting a little bit wetter, although we're pretty close to about 50 inches of rain a year here. Of course, we know that rainfall over the course of a year doesn't necessarily mean much. It really depends a lot more on how it falls. And when we look at just the most extreme days of 2 inches or more in 24 hours, what we see is that the really heaviest rainfall days are increasing by about 27% here in the southeast. But since the total rainfall isn't really changing that much, it means there's longer dry spells in between those heavy rain events. And so that means we have to worry more about erosive kind of activity. We have to worry more about those longer dry spells and, as well as erosion, that more of that water is running off, so it's not getting into the ground. And so that can change the soil moisture as well. Changing more in other parts of the country, especially in the Northeast, where a lot more rain was previously snow, but now they're getting more rain than they used to. And not much change out west, so that's really interesting to see that. We look at how drought has changed over time. You can see this particular timeline shows the percent of Georgia that's covered in drought. The brighter red or darker red it is, the worse the drought is. And this timeline starts in 2000. That's when this particular product was produced, and goes through the present. When I came in 2001, we were in a drought, went away in about 2003. We had a couple of pretty wet years, including some tropical activity like Hurricane Ivan and Katrina that brought rain to Georgia. And then in 2007, we had another drought that was mostly in North Georgia. You can see the second figure on the bottom there shows where most of that drought was. It was in North Georgia. Atlanta was talking about running out of water. In Athens, our reservoir was down by 14 feet, so they were worried about it here as well. That one went away, and the next drought in 2011 to 2013 was mostly a southern Georgia drought. And so that one actually was worse for most of the state, but because it was not the big media market that Atlanta is, didn't get nearly as much attention. And since then, we really haven't had any of these big multi-year droughts, at least not yet. The next biggest one was probably the 2016, 2017 drought, which started up in the Tennessee mountains. You might remember all the forest fires around Gatlinburg, and we had a lot of smoke that even came down here into Georgia because of that. Since that time, we've had a few shorter-lived droughts. The last drought that we're really still in now is a drought that started in the fall of 2025 and has reduced a little bit somewhat, but you can see the map on the very top right there. It's definitely the worst in the southern part of the state. We'll talk about why that is in just a minute. Sooner or later, we're going to get another one of these multi-year droughts. I don't know when it's going to happen. They do happen more often in years following in a La Nina, and we'll talk about that as well. We look at longer term changes in the climate of the US. The areas in the left graph here, or the left map here, which is annual temperature trends, anywhere you see a red, it means the temperature is increasing over the last 100 years. If you see blue, it's been decreasing over time. And that is mostly confined to the southeast. We called it the southeast warming hole. That was caused by that cold period that I talked about earlier, caused partly by land use changes, but also by burning of coal in the Midwest. And that is going away. That is not expected to be around much longer. Temperature trends across the U.S. are expected to be increasing everywhere, even over the longer time period. So that's something that we need to keep in mind. But it also tells you that if you're talking to somebody in a different part of the country, their experience may not be the same as yours. So that's something to keep in mind. You can see winter temperatures are getting warmer over almost everywhere in the country. Summer temperatures, not as much. I think probably that's due to increases in irrigation and more, our agriculture, so that we're getting more clouds in the summer because there's more rain and more cloudiness. And so temperatures are not increasing in the summer as much as they are in the winter. If we look at changes in precipitation on the right map, almost everywhere in the country is green, which means it's getting wetter over time, just like it is in the graph I showed of Georgia. Georgia changes are pretty small, but in other parts of the country, they're quite a bit larger. I know that in North Dakota, they're now growing corn where they could only grow wheat before, because corn requires quite a bit more rain than wheat does. And so we're starting to see farmers respond to those changes. Doesn't change everywhere the same. You can see the seasonal changes. Spring in the southeast here is getting drier overall, and fall is getting wetter, and that could change the way that you have to manage land, because if it's drier, then you might be able to do some harvesting in lower lying areas where it's normally too wet to get in heavy equipment. But in fall, you're less likely to be able to do that. We look at projected changes in the future. A lot of uncertainties about that, just because it depends on how human behavior is and what changes are made in the fossil fuel that we use and the amount of renewable energy that we use and so on. So all of those are very speculative, but in every single case, we know that temperatures are going to continue to rise because of the increases in fossil fuels and the increases in carbon dioxide and other greenhouse gases that are in the atmosphere. But we don't know exactly how much it's going to be. We just know it's going to increase probably somewhere between 5 and 10 degrees Fahrenheit. The Arctic is getting the fastest just because it's losing snow and ice cover. Those are areas that are usually pretty white, and they reflect a lot of sunlight back to space. So they're getting a lot more energy coming in and warming things up at the surface than they used to. Also important to keep in mind that these computer models that they use to do these predictions are really modeling things like the average temperature, not always the most useful thing, because it doesn't really tie exactly to things like growing season, which are more important for farmers and other agricultural producers. Precipitation in the future is also expected to change. Overall, the Arctic is really going to get a lot wetter, and a lot more of it's going to be rain, and less of it is snow. But they'll still get snow because it's still going to be cold in the winter. You can see almost every part of the country, with the exception of the Southwest, is expected to get wetter than it is now. There's obviously some seasonal differences. Southwest could get drier, and we're starting to see that variability in some of the drought there. All of that's going to affect things like water supplies, and so will also affect things like infrastructure, because as a lot of those areas that didn't used to get as much rain are now getting it. Their designs for bridges and their designs for roads are really not, set to handle that heavier rainfall. Not as much of an issue here in the Southeast, but certainly an issue that we have to concern ourselves with too. If you're worried about transporting things, then if a bridge washes out, obviously that causes problems. We look at other ways that climate change can affect forests. We do not necessarily expect to see more hurricanes, but we think that they're going to be stronger in the future because there's going to be more energy in the system. Stronger hurricanes mean they're likely to have stronger winds, which of course can cause damage to trees. And so that could be a concern. We also know hurricanes are likely to be moving slower than they were in the past. That means more rain. More rain means more flooding in low-lying areas, more erosion, and so on. So that is something that we do expect to happen in the future. And so ice and snowstorms are pretty rare here in the Southeast already, with the exception of this year where we had at least one of each. But overall, they're not going to change that much. We're still going to get winter from time to time. So they're not going to disappear completely, except for if you're really, in Florida or something. Even Florida this year got some really bad frost. And so we can't really identify trends in that very well. We do know humidity is rising with temperature because we have the Gulf to our south and the Atlantic Ocean to our east. And both of those are getting warmer as well as our land is. And so there's more evaporation coming off of there. And we're in the downwind path of all that moisture. And so we are getting more humid. That does have some impacts for things like fungal diseases. If we have more humidity, then we can expect to see fungal diseases cause more issues in the future. If we look at some of the other ways that climate change is affecting forests, we do see that increases in temperature can cause more dry soils. We're getting more runoff. We're getting more evaporation. That could increase the chances of large forest fires. The map here shows where they expect the number of weeks of the risk of very large fires to occur. Of course, you're probably not surprised to see the Appalachian Mountains because there's a lot of trees there. And as we go through drier periods, there could be some increases in these occasional droughts that cause forest fires. Along the coast, we're also expected to see an increase in the number of very large fires. Part of that could be due to warming temperatures. Part of it could be to damage from tropical systems that come in and blow trees down, making them a real source of fuel. We also think that some of the coastal forests will probably die off because of saltwater intrusion. If you're right along the coast, as sea level rises, we're expecting to see more intrusion into the aquifers there, and that will kill off some of the trees in those low-lying areas. And so that may cause problems in the future with the number of forest fires that are likely to occur. Another thing that we think is going to change is the mix of tree species that we have in different parts of the Southeast. As things get warmer, those species are going to migrate. And so this is one projected change of what the kind of tree mix will be. On the left shows in the recent past what that mix has been with more longleaf and slash pine in the southern part of Georgia, more of a mix of longleaf and loblolly and shortleaf in the center part, and then more deciduous trees in the northern part. That's going to change. A lot of the pine is not going to do very well in the new climate. Some of it will do fine, and we may see a switch to different kinds of pine that were used commercially. But there may be a change to a different kind of tree species altogether. And so that is something that will be interesting to see. Of course, every time you get a change in that also changes things like the bird species and the animal species that live there. And so those are all expected to move over time. If you look up in the northern part of the country, you can see big changes. If you like maple syrup, for example, a lot of the maple, beech, and birch is going to move so far north, we're not really going to really be able to grow very much of that in the United States anymore. So that will be one of the consequences of this warming climate over time, and something to keep in mind. Some of the other projected changes to southeastern forests will be things like red spruce and eastern hemlock are already declining. They'll probably just disappear. Conditions for pine growth may deteriorate, and a lot of the commercial pine growth may move farther to the north, to North Carolina and Virginia, or they might change the kind of pine that they're growing. So that'll be something we'll have to watch as well. Obviously, managers will have to choose what kind of seedlings they want to put in the future, and that will be determined, at least in part, by what the climate is likely to be. We put a tree in the ground, it's going to grow for maybe 30 years, depending on what the use of it is. And so you have to make sure that that tree is going to do all right in the warmer climate of the future. There's going to be a lot more water demand from urban populations, which of course are growing. And there's going to probably be more drought, so there's going to be more water shortages and stream flows in some areas could probably be reduced, which means that trees that are along those streams could see problems with water, or at least changes in the way the water's delivered to them. And we also know that the warmer temperatures may affect soil and organic matter decomposition. We don't know how that's going to affect nutrients in the soil yet, but it certainly may have a factor. We also know warmer temperatures and more evaporation, drier conditions will increase the number of fire hazards and also likely insect and disease outbreaks. So those are all things that we have to think about in the future. Not all the changes are going to necessarily be bad. We know that planting trees is a good way to absorb carbon in the atmosphere. And we also know that the more carbon dioxide in the atmosphere will probably fertilize the plants to some extent. But the big question there is there going to be enough moisture for that growth to occur? But it also increases the growth of other things that may not be so desirable, like exotic species or invasive species, and even things that are native, like poison ivy, are going to really grow very well in higher carbon dioxide atmosphere. And so that is something that will compete with the trees for nutrients. We need to keep in mind other parts of the country are going to be more severely affected in some ways than the Southeast, especially the Southwest. So that will affect markets and ability of people to come in and harvest those trees. Population growth will increase demand probably for lumber and other wood products. So that could be something that could be beneficial to foresters in the Southeast. And again, the market for carbon sequestration is something that I think farmers here, producers, may be able to take advantage of. Another thing to keep in mind is that not only is it affecting the climate for trees, but it's also affecting the conditions that our outdoor workers have to work in. It's going to be hotter in the future. The number of days over 90 degrees will impact the use of things like air conditioning, will impact the ability of people to work outside for long periods of time. So heat illnesses may go up. You may have to give workers more frequent rest breaks or not work them at all in the middle of the day if it's really hot. Also could affect road conditions. If the roads are hot, they could buckle and it might be hard to get lumber trucks in and out. So there are ways to manage that by doing maybe more overnight or early morning work, maybe some more automation, but some of those will require the use of more fuel, which of course is not good from a greenhouse warming perspective. But that's something that's definitely, in addition to the effect on the trees, you also have to consider the effect on the people that are working with the trees. So the bottom line for these long-term trends is that we do expect temperatures to rise 5 to 10 degrees Fahrenheit in the next century, maybe even half century. Growing season is going to probably increase by about 1 week per 1 degree Fahrenheit. So we could see an extra month of growing season by the end of the century. Precipitation could increase or decrease, but we know evaporation is going to increase because of the warmer temperatures. And more of the rain will probably run off because we get more of these high intensity rain events. Both of those could decrease soil moisture. So that's something that could affect tree health and the kinds of trees that you want to plant. Winter storms, we think, will probably decrease in frequency, but they're not going to necessarily disappear. And we're still going to see high winds from other things like hurricanes. And so that could actually increase just depending on the number of severe storms that we get in the future, which is really not very well understood yet. Tree species are going to migrate north over time, and we might see some more tropical species come in. I know in agriculture, we're now seeing olives and citrus growing in Georgia and other places in the Southeast. So that will change over time. We also know that there's other things that are affecting foresters as well, like competition for forest land from either agriculture in cities. A lot of agriculture in California will stop because it will just be too dry there, and they're going to have to move that agriculture somewhere else. And the Southeast may be one place that happens. And we also need to keep in mind that they're still going to have seasons, and there's going to be a lot of climate variability from one year to the next. So we're still going to have to deal with that. So I want to spend the rest of my time here talking about 2025 and then what to look forward to in 2026. These are maps of Georgia for what I just picked for the growing season from last year, May through October. And obviously, it depends on where you are in the state. Generally shows that almost everywhere in the state was ranked in the top third warmest of all years. The only place that was really, really far above normal was the Southeast. You can see those more rust-colored counties there. Those were in the top 10 warmest of all years. And there's just a couple counties in the Northwest that were below that ranking in the lowest third of all of them. But most places in the state uh, have been warmer than the long-term average. And if you look on the right-hand side, the same thing for precipitation ranking by county of precipitation. You see the driest part of the state, the Southwest, with most of the counties there ranking in the 1/10 of driest. There's that nice green speck or green area to the east of Atlanta. That's the area I was talking about earlier, where there were several places that got over 10 inches in just a few days in early August. And that has kind of set the stage. If you 10 inches out of maybe 30 or 40 inches in the summer, it can make a big difference in the statistics. And so if you took that out, I think you'd see much more mild conditions as far as how wet things were. But one storm system can really make a big difference in the annual statistics. We know that drought has increased a lot across the southeast part of the United States this year. This is the drought change from the beginning, from really August 1st, the beginning of August to the present. You can see how much drier most of the eastern United States has become over that time. One of the biggest culprits, I think, was really about mid-August this year in Georgia. Nearly all the rain stopped. There was long time periods when there was no rain at all. Really caused a lot of problems for farmers that were trying to finish their crops off for the year. It caused a lot of problems for stress on trees as well. And so we are still in that drought now. It's improved just a little bit since then. But a lot of that is really, I think, linked to the lack of tropical storms this year. We look at the lack of at the tropical season in 2025. It was a fairly average number of storms, but nearly all of those storms stayed out over the Atlantic Ocean. We only had one storm. It was Tropical Storm Chantal that came across land, mostly in the Carolinas. Got some rain from that. Here in Georgia, we got nothing from any of the tropical seasons. The last time that happened was 2015. And one of the results of that is we got really dry in the fall because usually we get 30 to 40% of our tropical season rain from tropical storms or even, unnamed storms that are from the tropics. And so when we don't get that, we're more likely to get drought. And we certainly saw that in 2025. These were all, I think, caused by the fact that the Bermuda High, which really steers the tropical storms around, was relatively far to the east in the Atlantic Ocean this year. We're not quite sure why. That's sort of a relationship between a lot of different weather patterns across the northern hemisphere. But for whatever reason, it was farther to the east, and so most of the storms curved around that high pressure, which goes clockwise, as the purple arrows there show, and just kept all the storms off the coast, which was good from a wind damage perspective, but certainly not good from a rain perspective. We know that hurricanes can cause a lot of problems. So when we do get hurricanes, we get the beneficial rain. This is a diagram from Hurricane Helene, but we also get those really damaging winds. And for Helene, the strongest winds were to the east of where the heaviest rain fell. In fact, really to the east of where the center of Helene went, which went right over Athens. And of course, anytime you have those really heavy winds, you get a lot of wind damage to the trees. And Hurricane Michael, there were trees that were down for years and years afterwards. There was just a glut of lumber in 2018 because there was so much down. A lot of it was really tangled, so it was hard to harvest, although I think quite a bit of it was harvested eventually. But they also lost some sawmills, so a lot of timber production was reduced because they just didn't have anywhere to bring the wood. But certainly as we get more of these really strong hurricanes, we can expect to see damage from wind likely to go up in the future. So when we talk about predicting the climate of the next few months, we have to look at climate variability from one season to the next or from one even year to the next, we have variability that causes differences in the climate, mostly based on changes in the incoming energy from the sun, plus internal variability in the atmosphere, which is it always is wiggling kind of like a bowl of jello. Um, One of the internal variabilities that's the most predictable, as far as we're concerned in the Southeast, is El Nino and La Nina, and I'll talk about that in just a minute. Um, Other parts of the world can also affect things here. Changes in incoming sunlight, although really not sunspots so much, but longer term changes. Volcanic eruptions can cause that as well. If we have a very large volcanic eruption, like Mount Pinatubo in 1992, it blocks out some of the incoming sunlight and it keeps us cool for several years after that. So all of those are kind of things that can affect climate variability and lead us to be able to do some prediction of what we expect. For the Southeast, the biggest one is probably El Nino and La Nina. And El Nino is a situation where the Eastern Pacific Ocean is warmer than usual. And that's usually observed to be the strongest right near Christmas. So it's associated with the coming of the Christ child, which is why they call it El Nino. The opposite is what we're in now. And in La Nina, usually the water off the coast of Peru and Ecuador in the Eastern Pacific Ocean is cooler than usual. As you can see in the inset map there, the bluer water is cooler than usual, and that can stretch all the way from South America out to the middle part of the Pacific. You wouldn't think that would make much difference to the climate here in Georgia, but it actually does, because it's like putting a rock into the river. If you change the flow of the air in one place, it will affect things downwind. And so from that standpoint, we're kind of downwind from the La Nina occurrence. And so we do expect to see some changes in that. And you can see the pattern of the swings back and forth between El Nino, which is depicted on the bottom timeline here in red, and the La Nina, which is on the bottom timeline in blue. It's not exactly as regular as a heartbeat, but there is some regularity to it. We have seen some El Ninos, the red ones, the warmer time periods occur. The last one was in 23 to 24. And since then, we've had La Nina occur for a couple winters now. We went to kind of neutral conditions in the middle there, but we've been in La Nina for several years now, with the exception of that one El Nino, and makes a difference to what we expect as far as the climate goes here in the Southeast. Right now, we're in a weak La Nina. That means the ocean there is in the Eastern Pacific is still a little bit cooler than average, although it's changing very fast. And the prediction now is that we're likely to swing towards neutral conditions in the next month or so. Neutral conditions are often associated with late frost, so we'll be seeing about that. But then we're expected to swing pretty quickly into an El Nino. You can see the red bars on there are the predictions of the likelihood of El Nino occurring, and they grow gradually over the course of the first half of the year. And so that by the July through September period, we do expect to be in an El Nino. And the latest predictions are that it could come on even sooner than that. So whereas now we're expecting warmer and drier conditions than usual across the Southeast because of the La Nina, by next winter, we're likely to see the opposite. And in between, we'll be in more neutral conditions. Summer is not a time when its predictability is real strong because other things are more important. And the El Nino is weaker, so there's less of an impact. But what we see right now is that most likely the El Nino is going to come on pretty strong by the middle part of the year. El Ninos are associated with fewer hurricanes than usual, so we could see less tropical rainfall and less tropical winds than usual in this coming growing season. It really depends on where those storms go, though, so we'll just have to see about that. Another thing we had to watch this year, especially, is the polar vortex. Polar vortex is an area high up in the atmosphere that has very strong winds, and usually it traps the coldest polar air right underneath it, so it doesn't really bother us. But this year it's been weak for reasons that aren't entirely clear, and so it's allowed this cold air to bulge out, and we've had these intermittent bulges of really cold air with warm spells in between. And so that has been a problem that we've seen this year. It looks like it's going to continue at least for the next couple of months. The next 2 weeks, I think we're going to be quite warm, but by the end of the month, we could go back into cooler conditions, which could mean another chance of frost. We'll just have to see. This year, the polar vortex was very weak, and so the winds were very wavy, and we've gone back and forth with swings between really cold air and really warm air happening pretty quickly. So where we are now, the last few minutes, departure from the normal temperature. This is from December 8, so it's the last 60 days. It's about the beginning of winter, which is December, January, February, shows that overall the state has been just a little bit below normal for the average temperature. And some places are still above normal. A lot of that is because of the cold weather that we've had for the last 2 weeks or so. Before that, we would have said we were above normal for temperature. We're going to go back into warm conditions, so the winter overall could still be above normal in temperature. For precipitation on the right-hand map here, you can see everywhere in the southeast has been much drier than usual for this winter so far. Very typical for a La Nina winter, and I think really the worst conditions are really in southeast Georgia and down in southern Florida, where some places got less than 25%. That doesn't even include how dry it was earlier in the fall. So those all contribute to that drought that we've been seeing growing across the eastern part of the country this year. We look at the expectations for mid-February, so this is about the time when your meeting's going to be held. Looks like it's likely to be pretty warm for the next couple weeks after the cold front that we're in the day that I'm taping this has moved through. Warmer conditions are expected to come in. We should get a little bit more rain, at least we hope so. And that will dominate the middle part of February. If we look at the end of February, this is weeks 3 and 4. So we do expect we'll probably swing back to a little bit colder conditions, although we'll see. It's far enough out that the predictions are not very good that far out. Not much of a sign in precipitation. It looks like maybe a little bit above normal is most likely in Tennessee. If we look at the longer time period, February through April, the pattern here shows very definitely that La Nina is the expectation. Warmer and drier conditions in the southeastern United States and really across the whole southern part of the U.S. With wetter conditions and colder conditions up in the northern part of the country. And wetter conditions, especially in the Ohio River Valley, which would be good for them because they've been very dry as well. And they're looking at going into their growing season, really wanting that moisture. We look a little further ahead. This is May through July. The prediction for temperature is that we're likely to be above the long-term average. Not a surprise because, as the temperature trend is upward, you're much more likely to get an above average year than you are a below average year. So that's really reflecting that long-term temperature trend. And then the seasonal precipitation, they do have an expectation as we go into the early part of the summer to go into wetter conditions. This is mislabeled, so it should be for the precipitation, that's for the summer. And I think that's showing they're likely expecting some more rainfall from probably tropical systems, even though we don't necessarily expect a lot of them. But if they do occur, we should see more rain in the summer months. The rest of 2026, we do expect El Nino to appear by midsummer. The biggest impact is going to be to reduce the number of hurricanes. So we think the season will be less active. But again, it only takes one to cause a lot of damage. So that'll be something we'll have to watch. El Nino in the fall could mean an early start to wetter and colder conditions. This could happen even in September. So if you're going to do any harvesting in areas that are affected by rainy conditions, you're probably going to want to do them early in the year and not wait till fall, just because of that. If El Nino strengthens quickly, that could happen even sooner. Next winter, we think the El Nino is going to be in place. So next winter should be wetter and cooler than normal across the whole Southeast. And that means that probably the year after that, 2027, is less likely to have a drought. 2026, I think we could see a drought, especially early in the year because soil moisture is so low right now, and there's no sign that it's going to go away anytime soon. So that's really what I'm looking for going through 2026 and then on into 2027. And I'm going to stop there because my time is just about up. Appreciate your attention and your listening. If you want to contact me with any questions, my email is here, my phone number is here. And I encourage you, if you want to see your local weather, to go visit the UGA Weather Network at weather.uga.edu. Thanks again for your attention and for your invitation. I appreciate it.